Alrighty, let's take a look at this question. So this question was on the 2017 Math 30-1 Diploma in Alberta and Numerical Response 5. And at that point in time, 72.3% of the province of the ones who wrote it got it right. So let's take a look at this one. So we are given a polynomial function. But as you notice, we're missing some things. This b parameter is in there. And then they tell you b is an element of the natural numbers, which means b is going to be 1, 2, 3, 4, 5, 6, something like that, right? Okay, has a factor of x plus 1. Now we know by remainder theorem / factor theorem that if they say it has a factor of x plus 1, that means x plus 1 equals 0, solve for x equals -1. If we sub that into our polynomial for x, that the remainder, since it's a factor, the remainder would be 0, because if something is a factor, it goes in nicely. So the remainder would be 0. Now, that's how we're going to find that missing parameter. And really, anytime you see a missing parameter like that in the equation, with polynomials, quite often you're using remainder theorem or factor theorem. Okay, so let's do that. Let's sub in -1 in for x. So we're going to go, and in for y, we'll go 0. So 0 equals -1 cubed minus 7 times -1 squared plus b times -1 plus 2b. Okay, we'll simplify that a bit. -1 minus 7 times -1 squared would be -8. And then plus b times -1 is -b, plus 2b would be positive b. And then solve for b, and you get 8. So let's rewrite the equation now. Y equals x cubed minus 7x squared plus 8, because that's b, x, and then 2 times b, so 2 times 8 would be 16. Now, really, at this point, and this is probably why the average was around 72, you could just put that into your graphing calculator. You'll get this graph, and as long as you know, looking at this equation down here, which one of your x-intercepts, because each of these factors gives you an x-intercept if you set it equal to 0, like x plus 1 equals 0, x equals -1, that's this one here. Now, the other one, the reason why we know, for a couple of reasons actually, why this is the other one, there's a bounce off that x-intercept, and that bounce comes from that exponent of 2 on that factor. So, like I said, you could just put it in your graphing calculator and use the trace button or a 0 button. It might have a hard time finding it because of the bounce, but and you would figure out that that value is going to be 4. However, if we want to push ourselves a little bit, let's look at doing it algebraically. So we now have the polynomial function, so we're going to divide using synthetic division, -1 into that. I use the adding method, which I find easier, so that's why I'm putting x equals -1 as my thing I'm dividing into. If you do the subtraction method, you would have a positive 1 there. Okay, so carry the 1 down, multiply, -1 times 1 is -1, add, which gives you -8. Whichever method you do use, you'll get the same result on the bottom row there. And -1 times -8, positive 8. Add those two, you get 16. -1 times 16 is -16. Add 16 and -16, you get 0. That's your remainder, which we knew was going to be the case, right? It better be 0, because x plus 1 was a factor. All right, now we turn this back into x's. We started with x cubed. We divided by x, so this should now be 1x squared, or just x squared, minus 8x, decrease it each time, plus 16. All right, now we're going to factor that, and we're looking for two numbers that multiply to positive 16, add to -8, and that would be -4 and -4. Which means you could write that as x minus 4 squared, and if you take that other factor, x plus 1, that is that polynomial completely factored. And if you compare that, the value of a would have to be 4. And that's your answer. Alrighty, hope that helped.